Hello everyone and welcome to the second video in my AX60 restoration series. So in the last video we did the repair and that went fairly well actually. It was pretty dead when I started and now it kind of sort of works. So the only other things we've got left are really just to replace some of the switches which aren't working. But apart from that, the operation is okay. All we have to do is clean it up now. So this video will mostly be concerned with making it look good. So we've got a lot to do. For a start, there's lots of dust in around the plastic inserts here. And it's generally not that clean. So I'll probably take the whole top panel off and remove all the circuit boards, and then it'll allow me to get in with some water and soap and a toothbrush and make sure we get all the dirt off. And while the panel boards are out, we'll replace the any dead switches. And also, which you may have guessed by the title of the video, we're going to replace the sliders with these, the Burns LED sliders. So they're a similar slider to what I used in the Akai AX, except they're a bit shorter. So they're only 30mm travel, and they nearly fit in the AX60 circuit board. They're so close. We're just going to modify a couple of these pins, and then we're right. So I'll show you how to do that. And when these go in the AX60, they look absolutely awesome. They're stunning. They really look good. And the way I know that is because I've done this before. So here is one I prepared earlier. So this is my AX60. I searched the world for it, to be honest. I ended up getting it from New York, which is pretty much on the opposite side of the planet. I like this synth so much that I decided to get a really good one and put the LED sliders in and just see how it worked. And it turned out really well. So it suits this synth really well. The black shaft of the sliders suit the top, and the red suits the LEDs that are naturally on the synth. So it's just one of those mods that turned out better than I expected. So I'm really happy with that. So we're going to definitely do that with this one. The only other mod I've done to this synth is bring some LEDs out to the front panel. So in the first video, I showed you how to put some LEDs on the voicing board to show which voice was active at that time. So all I've done is exactly that, but bring the wires a little bit further and the LEDs out to the front panel. And that allows me to see which voices are active while I'm playing. And that's really great for troubleshooting, because sometimes you don't notice that some voices are a little bit odd until you're in certain patches or you're playing it a certain way. So that really makes a big difference. So if you have a look here, if I play a key, I can now see which voice. So that's voice 1, voice 2, voice 3. And it's the same with chords actually. If I play a chord, oh, it's hard with my wrong hand. See? So that is awesome. Unfortunately, I'm not going to do that with this synth because I really don't need to. It's just a thing for me to troubleshoot. But anyway, it's in the first video if you want to know which resistors to attach your LEDs to. So we're going to get started. First, I'm going to remove the two panel boards and the output and chorus board. So to get the chorus board off, there's just these two clips here, and there's also two screws behind the synth. And you'll need to take off the tuning knob as well. These cables on the end are the output cables, so they carry the audio signal from the voicing board to the output board. So before you take off the panel boards. If you have any sliders left on your AX60, you'll need to remove them before the boards will come out. And I usually leave this screw as the last one, because as soon as you undo that screw, this cable comes loose and the whole panel will fall back. Make sure it doesn't fall against a wall or something. Okay. And then the boards just lift towards you and then out. So after that, there's two things we've got left to do to get this top panel off. One is to remove the on-off switch, and that just has two screws that come in from the rear of this panel. Once we undo those two screws, the on-off switch comes out. And the only other thing is to remove one of the side panels, because the great thing about this top panel is it's not held on by fixed hinges that are screwed on. It's just two pins, one on either side. There's a pin on this side panel and there's a pin on this side panel. So if we just take one of the panels off, that frees up one side and we can pull the panel and off the pin on the other side. It's pretty obvious that you'd never do this kind of stuff with the power on. I shouldn't really have to say that. So to get the side panel off, there's 4 screws, one at the front, 2 on the bottom and 1 at the rear. And there's another 2 screws on the inside of the panel. Now, before you take the side panel off, make sure you hold the top panel, because as soon as this side comes off, the pin will come out and the whole top panel could just fall. So now you can see it's loose, and we just pull the panel free of the other pin. And that's it. And it's time for a clean. So I've just got a toothbrush and a little cloth thing and soapy water. And the objective is just to get the dirt out, particularly from around the inserts. Now, the plastic inserts you can actually remove. They're just glued on the back. But then you've got to glue them back on after you clean them, and it's a bit of a pain. So it's probably better just to use a toothbrush. The only time I take them out is when they're already half falling out. There's a couple of AX60s I've seen where these, like one side, the glue's fallen off and the insert's been pushed down a bit. But it is a bit of a pain to put that glue back on. So the best option is just to use a toothbrush. It's also the quickest. So let's do it. And then I'm just finishing off with the cloth to try and get as much of the surface clean as I can. So it's dry now. It's pretty much the best I can do for the clean. At least it's removed all the dust and dirt. The panel's not in super condition. There's still some little spots where the paint's not very good, but at least it's clean now. So I can move on to the panel boards. And here they are, the panel boards. So, as you can see, they're in awesome condition. We've got a lot of dust to clean up. This is relatively normal, though. You'll find this in a lot of old synths. This slider's my favourite, look at that one. Some of the switches are already clean, because I cleaned them before, but what we're going to have to do is strip the whole board pretty much. So the sliders have to come out anyway because we're replacing them. A lot of these switches underneath here were faulty, so all the switch caps will have to come off and the switches will come out. So we'll be left with a rather empty board after that, and I'll be able to wipe the dust off the top. Then once it's clean, I'll start modifying these sliders and I'll get them all ready, and then we'll place all the new sliders in. We'll reuse these dust covers because they're still sort of okay, and then put all the switches back on and the switch caps, and we should be done, and we can start testing exactly the alignment of the sliders. They don't go in exactly in the same position, so we will need to double check that they line up correctly in the slot of the front panel. But most of the time there's not much adjustment to do. And after that we will install the wires to get the LEDs lit. Okay, so to get the dust covers off, there's a screw at the bottom and another one at the top. They're not on every slider. The groups of 2 and the singles have them, but the groups of 3, there's the middle screw isn't there, so you just skip it. And then you just lift the dust cover off, and we will clean them later on. So next are the switch caps. The single ones are really easy to get off, but the groups of 4, they're a little bit harder. So, same concept though, they've all got these little arrowhead clips. So you just squeeze them together from the rear and it drops down. So that's pretty easy. Right, so our switch caps are off. And we've got a lot more dust now to clean. Yeah, it's pretty bad. That's okay, we'll fix that. So next we'll remove the switches and the sliders. So to get the sliders out, I usually add some solder first. And then I get the smallest screwdriver that I've got and just place it underneath the slider to gently pry it up while I heat the pins on the other side. So all the sliders are out, well, all except for 2. These 2 on the left hand side, they're made a little bit differently to the other sliders. All these ones are 10 kb, and it's easy to find replacements for those in the Burns sliders. So we can get a normal 10 kb slider and put that in. But these 2 are different. One is the volume, and this is a dual 10 kb, it's 20k slider actually, so it's a dual 20k slider. So there's actually 2 sets of tracks in here, whereas the normal Burns LED sliders, they only have 1 set of tracks. So we can't replace that slider with the LED sliders. And the other one is the split level. Now the split level has a center stop, and this is quite a strange slider. It's more than likely to be a custom made slider, and that's because it's like 2 sliders in one. So the center is actually a ground, and then when you move it one way you've got a 10k slider, and when you move it the other way you've got another completely separate 10k slider. So it's as if you've got 2 sliders back to back with the starts in the middle. So again, we can't replace this slider with the standard slider. So with this synth, for just ease of installation, I'm going to leave the 2 original ones on the left hand side. Now when I did the other AX60, I actually modified the circuit board so that I could put 2 LED sliders here. But what I had to do was remove this one, the volume slider, and turn that into a dual gain pot. So that's now an audio taper dual gain pot for the volume, and that gave me a spare spot here. And then I split this slider up, which is made of 2 sliders, and I took the bottom 10k slider and moved it over to here as a separate. So now I've got 2 10k sliders here, one for the upper split and one for the lower split, and the volume slider has been replaced by a pot. So if you have a look over here, I've had to relabel the top of the synth. So we've got lower split and upper split. Now this used to be the split balance, but yeah, because the LED sliders wouldn't fit in, I've had to split that up into 2, which means I've been left over with a volume pot. But that's not so bad. I like having a rotary volume pot, and the sliders look good there. But the problem is that took a lot of modifications to the circuit board. I had to flip it over and cut a whole lot of tracks and put in new wires and everything, and it took quite a while. So I'm not going to do that with the other synth. And I don't suggest that you do it either. It was a bit of a pain in the end. It turned out well, but it's a real hassle. So I'm hoping that if we just leave those two sliders in on the end, that it still looks good. So we'll have LED sliders and all the others, and just where the levels are, we'll have the normal sliders with the caps. So we'll see what that looks like. Okay, so the next step, before I put the new sliders in, I'm just going to remove all the old switches, and that'll allow me to wipe the board of all the dust. Because if I start putting the sliders in now, the board starts to get crowded again and it's harder to clean. There's a slightly different strategy for removing the switches, and that's because they're bent over the pins. So you can see here the pins are a little bit bent over. If we tried to pull that while we're soldering, we may not get the switch out properly. We can start having problems. So by far the easiest thing to do is to cut off the bent over legs before we start. That makes it really easy. Once we mount the solder, the switch then just falls out. So if we just go along and cut all the legs off the switches, then it makes it much easier when we come to pull the switch out. Okay, the switches are out and the board has been cleaned. So the next thing I have to do is modify these burn sliders so that they fit. So I've drawn a diagram of each of the sliders, the original sliders in the AX60 and the LED sliders from Burns. The orientation is as viewed from above. So these pins are underneath. So the main differences between the two are obviously that the Burns slider has connections for the LED and they don't fit on the circuit board, so we'll just bend these pins up and leave them above the circuit board. Now the other two pins that connect the carbon track, we're quite lucky because they're the same pins on each slider. So on the Burns slider, the pins are in the same position as the original. So the only difficulty we have is that the pin that connects the wiper on the carbon track is actually on the wrong side. So on the original sliders, it's on the inside of the pin that connects to the carbon track. On the Burn slider, that wiper pin is on the outside of the one that connects the carbon track. So we have a problem. The really great thing is, on the Burn sliders, there's a pin that's not used, and it's on the inside of that carbon track. So all we have to do is bend this wiper pin around and connect it to the unused pin. And once we do that, we have our 3 pins for the resistor are in the same position and it'll fit in the board. So I'll show you how to do that now. So the first thing we do is bend these pins outward a little bit. Because on the normal sliders the pins extend from the outside of the slider. So these ones are a bit too far in. Okay, so now we've bent the pins outward a little bit. Now the next thing we do is actually just cut a little bit in between these two pins, because there's like a flange that means they're not quite far enough apart. So if you have a look at the original sliders, the pins are just a little bit further apart than the Burns ones. So we'll need to separate the gap in between the pins a little bit. Okay, so now our pins are far enough apart. Then the next thing to do is bend this wiper pin around to the unused pin. So I usually bend it up first and then use a smaller pair of pliers just to start bending that pin around. And you just keep going until the pin eventually touches the other one. Okay, so there you go. It's bent around now. And then I'll solder that pin on before I go any further. Now I use lead-free solder when soldering the two pins together. And that's because the lead-free solder has a higher melting point than the leaded solder. So when I solder this slider back into the panel board, if I use leaded solder and just quickly solder that pin, hopefully I won't remelt this solder joint because it's of a higher melting point. And last of all, I bend up the two legs that connect the LED because there's no hole to put them into or through the board, so they have to sit on top of the board like that. So that's a finished slider. Okay, so putting them in is really easy now that we've prepared them. I just slide in like that. So I'm going to put in all the sliders and all the switches and the switch caps, and then we will do the power for the LEDs. And the reason why I'm going to do all those other things first is because in some places, like here, that pin for the LED power is a bit squashed up against where the switch caps are, so we're going to need to bend that pin up. In fact, I'm going to need to bend that leg up before I put the switch in, because this switch won't even fit while the leg's still there. Okay, so the switches are in and they're not interfering with the pins on the sliders anymore. And I've started wiring up the sliders and I've gone as far as putting in some resistors to set the LED brightness. But before we talk about that, we need to talk about the power supply, because we need to know where we're going to get the power from to power the LEDs. And that's important because a lot of synth power supplies are quite stressed as it is. So we don't want to stress them anymore by putting a whole lot of current through some LEDs. So we really do need to take the current down of the standard LEDs quite significantly to get it in the range that doesn't stress out the power supply. Now the only way to do that is to use high brightness LEDs instead of the standard low brightness ones. So if we use high brightness LEDs, we can use much bigger resistors, have much less current running through them for the same brightness. So the next question is, where do we get the power from to power the LEDs? Now, if you touch the top of the AX60 panel, you'll notice it does get a bit warm. And most of that heat is coming from this area here. And these are the two transistors that help control the plus and minus 6 volt supply. And they're switched on and off by a little IC that's sitting behind them. But it's the two transistors that do all the work. And they have quite a large voltage drop across them because they're being fed from these plus minus 15 volt regulators, and they're only outputting 6 to 6.3 volts. So there is a lot of heat that's going to come off them. And also, not only do they feed all the voice chips and all that kind of stuff, there's some Zener diodes in front of them, which the 5 volt supply is derived from, so they also drive all the logic and the CPUs and stuff like that. So this whole area is already getting quite hot. So really the only part of the power supply that we've got any spare capacity is in these two regulators at the back, the plus minus 15 volt regulators. So the best place to get the power from the LEDs from is here. That presents us with a problem though, and that is because this is 15 volts. We're way too high for the LEDs, and most LEDs would have a voltage drop across them of about 2 volts to maybe 4 volts. So 15 is way too high. So to get that down, we're going to have to group some LEDs together. So that's what I've done here. So I've grouped these 5 together, And that means that if we consider that each of these LEDs has a drop of about, I don't know, 2.5 volts, that's about 12.5 volts. So we've only got 2.5 volts left to drop across this resistor, so this resistor won't get that hot. If we just put one LED, that LED would only maybe take 2.5 volts from that whole 15 volts, and we'd have to drop 12.5 volts across this resistor and it'd get too hot. So that's not going to work. So the only way to make this work is to start grouping them together in series. Now I can't really tell you what value of resistors to use because that will depend on what LEDs you choose and how many you decide to group together. So there's not really much more to say about that. So I'm going to complete wiring them up now and give them a test. And we have ignition! Look at that! Looks pretty good in the white actually. I planned to put blue in, but they were a bit of an epic failure because the blues were way too bright, and when I took the brightness down, the LEDs became really uneven. Like some of them were hardly lit and other ones were still really bright, and so it just became impossible really. So I thought a good compromise would be white because I wanted to do something a little bit different to the red. So there you go. That looks pretty good. So all I have to do now is put on the dust covers. So we need to give these dust covers a good clean, and then use these screws to put them back on the LEDs. Because the good thing about them is the screws still fit. And the dust covers are back on. They're all nice and shiny and clean now. It's amazing how much difference a clean makes. And they fit to the LED sliders really well, just like before. So, excellent, we're ready to put everything back together. And we're ready to test. Let's see if it works. Oh, that looks okay. I had my doubts about the white, actually. I think it looks alright. What do you reckon, the white or the red? Probably still like the red better, but the white isn't too bad. I've got a few other colours that I'd like to try as well, like a yellowy goldish colour to suit the AX60 riding. That would be pretty cool. And if worse comes to worse, I can just make this a red one again. But yeah, that was a success. So wow, it's been such a long journey with this synth. It's pretty broken when I got it, pretty beat up. Looked horrible, sounded horrible, and we've gone through and done the repair, and now we've made it look really good. So that's excellent. So thanks for watching. I hope you enjoyed it. I certainly enjoyed doing this one. It was a bit of a challenge. And speaking of challenges, the next few synths I've got are real challenges. I've got a Akai AX60 that had been left outside in the rain. I've got a Juno 106 with the simple kind of normal problems. And I've got a CS20M which is completely dead. So that'll be a good one. I'll do that at the same time I do a CS40M, so that'll be really good to compare the two. And then after that, I have a very special synth, which I will keep secret for a little while longer. Alright, that's it. Thanks. See you in the next video.